All right, I want to look at this problem in the textbook that's set out. It gives us the relationship 1 minus x squared over 6 is less than x sine of x over 2 minus 2 cosine of x, which is less than 1. And it says if this is true, which they say it can be proven to be true, though it's not the easiest of trigonometric identities to show. I've done it a couple times. I can get 1 minus x squared over 4 on this side, which is a little bit bigger, saying that for this, but that makes this true. I can get this related to 1 minus x squared over 4, and it relies on the sine of x is approximately x for small values of x, called the small angle theorem. And so since that approximation is true, I can rearrange this to look like this. I can get a factor of 6 if I play with some of the double angle formulas here. And the fact that to get this left-handed side limit, I have to come in from the left. So, as x approaches c from the left-hand side, x is negative. And so that sets up the factors to get the signs incorrect. If I do the same thing and I approach c from the negative side, if I approach c from the positive side, then x is positive, and things cancel out and go to 1. So I can get this identity. This factor here, I can get larger values. Honing in on this value depends on how I remove the cosine coming across. But the book's asking us to accept that this trig identity is done. It's not a trivial set of trig identities. It's about 6 steps in each version I did of this. And I might do a separate video on it at some point. But we'll accept that these are end caps on it, and that the signs, the plus or minus, affect how we approach inwards to this problem. But knowing that it's bounded, we now get the sandwich theorem coming out. And what we say is, well, this is going to approach 1. And what we want to see is why these two functions approach 1, which is what the text is asking. And so if we look from -2 to 2, which are small enough angles, and we'll take our right-hand bound, the constant function of 1, that bounds it there. And now we look at this left-hand side. Well, this is a parabola centered at 0, shifted up 1. So it is going to be there. And that -2, the squares, and so that answer is 1/3. And at +2, it's also 1/3. And so we have our our x sine of x, 2 cosine of x trapped in here. And so the sandwich theorem is able to be applied. I might do another video when I have a little more time on showing some of the manipulations we can to get these endpoints. But it does really rely on this idea that sine of x is approximately x for very small values of x. And that lets us get a x squared out of here. And if we change this using some trig identities to a sine function, noting that x is negative, well, then what we're really saying is we have negative x times x for that small approximation, which gives us negative x squared. And then this part here gives us a factor of 6. The 1 comes about because I have to multiply by the conjugate. The 2 plus 2 cosine of x gives me a 1 term that we can have over here. If I do the same manipulations but x is positive, then in the numerators and denominators do cancel each other out. And so it is a splitting here. But again, that's not really what the book is asking to go for, to find these two endpoints on it. It's asking if these endpoints are true, then what can we say about the sandwich theorem on this particular function.